These are the activities for College Algebra Lesson 24. For each of the first three problems, we want to write the polynomial function in completely factored form. Each of the problems gives a hint with how to get started. So number 1, x squared plus 81. The hint is obtain the zeros by solving for x. Okay, so the degree of this polynomial is 2. Highest power on x is a 2, which means it should have 2 linear factors and 2 zeros. So I'm going to start by trying to find the zeros. Find the zeros of a function by setting it equal to 0. That's why we call them zeros. They are the solutions when you set it equal to 0. Okay, so I can use the quadratic formula, or I can move the 81 to the other side. Right, subtract 81 from both sides, and then square root. So I'm going to get x equals plus or minus the square root of negative 81, which is plus or minus 9i. So I have 2 zeros. I knew I was going to have, there should be 2 zeros, and I have found them both, plus or minus 9i. So I can write this in completely factored form. My leading coefficient should be the same as it is for the original. So this is going to be a times x minus a 0 times x minus another 0. We called them c's in the demo. So my leading coefficient is 1, and my zeros are 9i and negative 9i. Number 2, g of x equals 2x squared minus 8x plus 9. This one suggests using the quadratic formula to find the zeros. And don't forget the leading coefficient. So the degree of this polynomial is 2. That's the highest power of x, which means I should have 2 linear factors and 2 zeros. I'm going to start by trying to find zeros, which means set the function equal to 0 and solve it. And the hint said to use the quadratic formula. So I'll say x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. And that will simplify to 8 plus or minus the square root. All right, 64 minus 4 times 2 times 9 is 72. So 64 minus 72 is negative 8 all over 4. And then I can simplify that negative 8. I'm going to rewrite that as negative 1 times 4 times 2. I'm going to square root the negative 1 and square root the 4, so that'll be an I, that'll be a 2, and then I'm going to leave this 2 under the square root because it's not a perfect square. So this becomes 8 plus or minus 2i root 2 all over 4, and then I can just break this into two fractions. 8 over 4 plus or minus 2i root 2 over 4, and reduce each fraction. So 8 over 4 is 2 plus or minus I root 2 over 2. So there are my zeros. There's 2 of them because of the plus or the minus. I have 2 zeros, which means I can know the 2 linear factors. So this should be leading coefficient times x minus 0, 1 times x minus 0, 2. My leading coefficient I already know is a 2. So put a 2 there. And then I'm going to have x minus, my first 0 is 2 plus I root 2 over 2. And my other 0 is 2 minus I root 2 over 2. And we've got it in completely factored form. Number 3, k of x equals x cubed minus 5x squared plus 17x minus 13. So it says find one zero using the table provided. So I'm looking for places where y equals 0, and I get x equals 1. So write that down. Okay, and then use long division and the quadratic formula. So first of all, this is a third degree polynomial, which means I should be finding 3 linear factors and 3 zeros. So I have one of the 3 zeros from this table. 1 0 is given. So I'm going to find another 0 by doing long division. So if x equals 1 is a 0, x minus 1 is a factor. So now I can find another factor by division. X minus 1 divided into the cubic polynomial and x times what gives you x cubed? X squared. X times x is x cubed. X times negative 1 is negative x squared, and I subtract. Those go away. Negative 5x squared plus x squared is negative 4x squared. Bring down the 17x. X times what gives you negative 4x squared? Negative 4x. Negative 4x times x is negative 4x squared. Negative 4x times negative 1 is plus 4x. Subtract. 4x squareds go away. 17x minus 4x is 13x. Bring down the minus 13. X times what gives you 13x? 13. 13 times x is 13x. 13 times negative 1 is negative 13. Subtract, and my remainder is 0. So I have 1 0 and 1 factor. Now I have another factor. It happens to be quadratic. So I want 2 linear factors to go with this third linear factor. So I need to break this down further. I think I need a little more space. I'm going to go to a new page and summarize what we have so far. Okay, I have summarized what we've learned so far. I started out with this cubic polynomial, and I found 1 0 by looking at the table that was provided, x equals 1, which means x minus 1 was a factor. And I did long division to find this other quadratic factor. I would like to factor this a little bit further, so if I knew all the zeros, then I'd know all the linear factors. So I'm going to set this equal to 0, set each factor to 0 separately. Okay, here I get x equals 1. I already knew that was a 0, but over here, this is going to give me 2 more zeros when I use the quadratic formula. So x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. Okay, 4 times 13 is 52. 16 minus 52 is negative 36. So this is the square root of negative 36 all over 2. So I have 4 plus or minus 6i over 2. I can divide that 2 into both the top, into both terms on the top, and I get 2 plus or minus 3i as my other 2 zeros. And once I know the other 2 zeros, I know the linear factors. So here's my cubic polynomial. Okay, I should be able to write it as a leading coefficient times x minus 0, 1 times x minus 0, 2 times x minus 0, 3. Okay, the leading coefficient, this a, is the same as the leading coefficient here, so it's a 1. So I'm just going to put a 1 there. And my first 0 I knew from the table was 1, so I have x minus 1 as my first factor. And then my other 2 factors are going to be x minus these 2 zeros. So x minus 2 plus 3i and x minus 2 minus 3i. And there is my completely factored form. Number 4, give an equation with real coefficients of a function with the listed properties. Give your answer in either factored form or standard polynomial form. Either one is okay. So this is quartic, which means it's 4th degree. Maybe I'll write that down. 4th degree. They told me the leading coefficient is 2, and it has zeros at 1, 3, and 1 plus 2i. So if it's 4th degree, that means there should be 4 zeros. They've only listed 3 here. But I know that complex zeros like this always occur in conjugate pairs. So I can say, and 1 minus 2i is also a 0. So I know the leading coefficient, and I know 4 zeros. I should be able to write this whole thing down. So I'm going to have f of x equals leading coefficient a times x minus 0, x minus 0,2, x minus 0,3, and x minus 0,4. I know there's 4 because it's fourth degree. So my leading coefficient, they told me, was 2. And then I have zeros at 1, 3, and 1 plus 2i, and x minus, my fourth 0 is 1 minus 2i. And they said I can leave it in factored form, so I'm done. Okay. If you really wanted to, you could multiply these all together and put it into standard polynomial form, but I am not going to. Number 5, give an equation of a function with the listed properties, again, either in factored form or standard polynomial form. Quintic, that means fifth degree. Which means I'm looking for 5 factors and 5 zeros. So they gave me a 0 of -1 that has multiplicity 3, so that's 3 of my 5. And they gave me a fourth 0 at root 2, that's 4 of the 5. But I need a fifth in order to write this formula. But I know that irrational zeros come in conjugate pairs. Think of that as 0 plus root 2, so 0 minus root 2 is also a 0. And then they gave me the y-intercept. I'm going to use that at the end to find the leading coefficient. So let's see, f of x is going to be leading coefficient that I don't know, times x minus 0,1, times x minus 0,2, times x minus 0,3, times x minus 0,4, times x minus the fifth 0. And I know there's 5 because it's a fifth degree polynomial. Okay, they did not tell me a this time, so I'm just going to leave it as an a, and I'm going to fill in the zeros. So -1 is a 0, so I'm going to do x plus 1 as my factor, and that's going to be a factor 3 times because that 0 has multiplicity 3. And then my other 2 zeros, I'm going to put in to the factors x minus root 2 and x plus root 2. And now I could multiply these together. I think I will because I need to do some more work on this. Like if I already knew a, I would just circle it and be done. But I still have to figure out what a is. And I think it will be easier if I have this simplified. So I am going to multiply the x minus root 2 times x plus root 2. And that is going to give me x squared minus 2. Just FOIL it out and you'll get x squared minus 2. And that's good enough. I think that's simple enough to be able to figure out the a value using the y-intercept. Okay, so I just moved the function f as far as we have gotten to a new page, and I brought this other piece of information that we haven't used yet, that the y-intercept is 0, 6. So when x is 0, y should be 6. We can plug the 0 in for my x's, 6 for the y, and I'll be able to find a. So 6 is a times 0 plus 1 cubed times 0 squared minus 2, and I get 6 equals a times 1 times -2, so a would have to be -3. And then I can finally write this out fully. F of x is -3 times x plus 1 cubed times x squared minus 2. If I wanted this completely multiplied out, it would take a long time, but I could cube this and then distribute this. I'm not going to do that. Also, I could put it in completely factored form where all my terms are linear, and I would have x plus 1 cubed, and then x plus root 2, x minus root 2. Like I had before, I multiplied these two together to make that. Either of these would be fine.